Hello and welcome to Climactic, the flagship podcast of the Climactic Collective. A podcast network by and for Australia's climate community. We're a group of podcasters who acknowledge the climate crisis, who understand we are in a climate emergency, and are engaging with our local communities by using and developing our storytelling skills. We're currently a collective of volunteers who produce this show out of love, fear, and rage at the challenges our societies face. We have ambitions to become a social enterprise media company, supported by our listeners. And if you enjoy the show and are able to help us grow, that's the only way we'll get there. By spreading the word about the show, you'd be helping us greatly. We want to welcome on board storytellers, interviewers, producers, editors, people with podcasting skills, or those looking to develop them. If you're able to support the collective monetarily to enable training and support to new members, and allow more voices to be heard, you can find our Possible account where you can donate even just $1 a month at our website or in this episode's show notes. Thank you for listening to the Climactic Collective, the community voice in these climactic times.
There are dire warnings that New South Wales will be hit by increasingly extreme weather.
2015 was the hottest year since climate records began.
Your show this July was the single hottest month in recorded history.
Australia sweltered through its hottest spring on record.
Climate change is now affecting every country on every continent.
It's the rate that's of great concern.
And what do you put that rate down to?
Oh, it's human activity.
We have everything we need. Some still doubt that we have the will to act, but I say the will to act is itself a renewable resource.
Hello, I'm Dr Renee Beale, Science Communicator and Curator at the Royal Society of Victoria. I'm delighted to be presenting this special climactic podcast for National Science Week 2019. Today I'm joined by Dr Darlene Lim, a geobiologist working at the NASA Ames Research Centre in California. Darlene, welcome to the podcast.
Thank you. Pleasure to be here.
So I just wanted to jump back to the beginning, if I could. We'll have a bit of a chat, bring you back up to speed, I suppose, about how you got to be at NASA and what you're doing currently. But you're actually a first-generation Canadian with your parents immigrating from Singapore.
That's right, yeah.
Before you were born. So what was it like to grow up as a first-generation Canadian?
Cold. It was interesting. So I grew up in Alberta, which is a province on the western side of Canada, and there wasn't a whole lot of diversity, if you will, at that point in time. It's different now. It was great fun. There were also some challenges associated with that, but there was never a dull moment, let's just put it that way. And one thing that I learned, and still, I think I still have to this day, is work ethic, because my parents, being immigrants, and I think this is, part of just being an immigrant's child, is you just know that your parents are going to work really hard all the time because they came with pretty much nothing and they had to build something from that. And the whole point was to kind of give myself and then subsequently my sister and I a better life. So that was a really interesting transition, and being in Alberta in terms of just opportunity to be outside, that's an incredible place to be. We could go camping in the summer, we could go skiing, eventually we went skiing in the winter, always ice skating around in the neighborhood and making snowballs, making, snowmen, and it was just part of growing up in Canada. And I still love the sound, the crunch of snow. I love the smell after it snows. I love even the dark winter nights, just something very soothing about that. And that stays with you for your whole life, and so you just kind of remember that freshness of being outside. And I think that's probably still motivating me to do what I do to this very day.
So that is really interesting, because actually part of what you do is absolutely being connected with nature and being outdoors now, even as part of your work at NASA. So were you aware as a school student that you wanted to do something potentially outdoors, or was that just something that was part of your life? Being out in nature was part of your life?
I think it's the latter. Yeah. Actually, what's funny is I actually loved ballet biology. I was pretty serious about that when I was younger, and I was kind of hoping that that would be the career. But, you know, life kind of goes through twists and turns, and what never left me was this love of the outdoors. And happily, it's become part of my job now to be outdoors and do work in these extreme environments. But yeah, I mean, absolutely. I think it's easy to, look back and connect the dots. I can't say for sure if it's always impacted me, but I have to assume it has, in some way. That's kind of the legacy I think that my parents have left myself and my sister, is growing up in this environment of Canada, embracing the outdoors. It's, like I said, become my livelihood as well to be in these environments and to study these environments. And then I've since passed that on, I think, to my children as well, and we spend a lot of time outdoors in California. It's a very interesting feeling that you get when you are outside and free and exploring, and that never leaves you.
So I think also there's part of it that having a childhood where you're immersed in that means that you're not afraid of those environments, because if we come up to now in terms of what you're doing, you're actually working at analogues, so Mars analogues on Earth. So there's some pretty extreme environments that to some people would be quite scary environments to be in, but obviously you've had quite an upbringing in the natural environment where you've grown up in those environments.
Yeah, that's a really great observation. Renee, I agree with you in that you're right. There are some things that I kind of take for granted that they didn't scare me. And I had to learn a lot of things when I went into my undergraduate years in biology, and then when I started my graduate program and such, in terms of operating in truly remote environments like the Arctic. And I learned a lot from the supervisors that I had for my graduate program. I learned a lot from just the people that I worked with. But definitely, you're right, just to get to that point, I think there were less hurdles in terms of it not being so foreign to be outside as it might be if you were, not, I guess, imbued with that interest from the get-go.
There's also, being out in those environments, there's sort of I think maybe an unconscious understanding or a feeling that you're okay, like nature's okay. Although it's hospitable, it's sort of, you're sort of surrendering yourself to that environment.
Right.
And I always feel like,
it's dynamic. Yeah, things are always changing. You never know what's going to come around the corner. Yeah, absolutely. You're so right. I think these are really spot on observations. And yeah, definitely, in this conversation, you're making me think about those little moments that they come up again and again, the surprises. You can always expect the unexpected. It doesn't matter if you're on a camping trip where now we always say, we practice a lot, or, in kind of quotation marks, we're in the lab, we're in our test environments, our safe test environments at work before we get out into the field. In fact, we spend over 90% of our time in those test environments and in meetings before we get out in the field, which is the remainder, sometimes it's 6 to 10% of our jobs, so it's not the bulk of it. But all of that testing, and yet you still get out in the field and something will be unexpectedly go awry or whatever. It's just part of being in a dynamic environment that you have to react to. And it's a great point. And I think that's also why I'm such an advocate for practicing for human space exploration in these remote, in these dynamic environments, because we're going to put ourselves not only in a very dynamic space when we go into back to the moon or onwards to Mars, but it'll also be an environment whereby, we're going to have to practice a lot, but you'll have to know how to deal with the unexpected, because that will be around the corner no matter how hard we try to control what we're going to be doing.
Excellent. So let's come up to speed now, since we're starting to talk about you at NASA. So you study earth science, biology, lots of things. So that's a great point. Obviously, you've being out in these environments, clearly just even getting to the point where you're working at NASA on these projects, you've actually been quite flexible and quite broad in what you've studied as well. So
yes.
You've kind of purposely flung yourself into various aspects of science.
Yeah.
And
I think the environment that I'm at NASA has enabled that. It's certainly been tough in some circumstances. There's like a very steep learning curve at the beginning when you know nothing and you got to come up to speed very quickly on something and then apparently make good decisions about what to do. It can be interesting, to say the least, but I love that. I love that challenge. I love having to stay, as calm as possible and intake all these different bits of feedback, whether you're in the moment, out in the field, or in a meeting, and trying to integrate and deal with all these different perspectives. I think that's what really drives me, and I know, deep down that we're going to need all these different perspectives to solve many of the large challenges that are coming our way, and to innovate our way out of the challenges as well. So it's really exciting to be able to interact with all the people I do, and I think it's just generally exciting times.
So you encounter NASA when you're postdocing, or were you PhD at that point?
So while I was doing my PhD, I actually got to work with a NASA-funded group, and they were working in a place called the Houghton Impact Structure in northern Canada, in the Canadian High Arctic, actually. And they were looking, funny enough, for a limnologist to come in and study some of the existing lakes and ponds in the area in terms of understanding how they've been changing over time. And then there was also an impact in the impact structure. There was a lake that built up, tens of millions of years ago, and they wanted somebody to also look at those lake sediments and understand some of the changes that happened there. Through that academic entry, basically I got involved with all the different aspects of that project, which included exploration topics to do with humans and robots exploring the moon, and in particular Mars. As the years went on, I kept going back to do my research and then to help with different aspects, and that was my real first kind of deep dive into analog work. Though I had been exploring life in these extreme environments, this was the first point of entry really for me during my PhD into this idea of integration and the idea of using science as a means to understand how best to design for exploration in the future. I met a lot of really generous people who were very kind to share their knowledge with me and help me grow as an academic, to grow as a person, and so forth, and to understand, leadership in those types of environments as well.
So you obviously keep researching collaboration with NASA, and then more formally joined some of the NASA programs. What was it like when you joined NASA as the Canadian and a woman of colour? That's not all that common, obviously.
It's not all that common. That's very true. I didn't go there because it was going to be easy. Mm-hmm. I went there for the challenge. I went there for the vision. I went there for the opportunity, and it has delivered and then some. Over the years, I've had to write a lot of research grants, put them together with a team of people. We've failed more than we've succeeded, but then when we succeeded, we've done, as much as we can to squeeze every last drop of productivity out of each one of those moments. And we've tried to work as a team and to present our work as a team so that not one person gets credit. And I think that sort of intellectual, professional goodwill has propelled the groups that I've been able to, be part of and to lead into more and more interesting projects and to further successes. And that, to me, has really been one of the underlying reasons why I get to keep doing what I'm doing. It's this sort of professional, innovative teamwork, that really helps us get to where we want to go.
So let's take a bit more of a deep dive into some of the projects that you've been working on.
Yeah.
And we've been skirting around the Mars analog terminology, and that's because we've had a couple of conversations about that already, but I thought, if we can come back to explaining what Mars analogues are for people listening, and then also talk about some of the environments that you've been using as Mars analogues.
Sure, yeah. So an analog is a place that we can visit on Earth that approximates in some way some sort of physical or operational condition that you're trying to simulate, and that could be, for example, a very cold, dry environment, which is meant to simulate, for example, the Martian surface, or it could be operationally bringing humans close into an asteroid and trying to simulate that, and you would use somewhere like an underwater environment. So there's all sorts of places that we would like to send humans and robots, and we send robots out fairly regularly deep into our solar system and beyond. But humans, we've had to stay in low Earth orbit, and since we sent humans to the moon, it's been the last 50 years have seen us predominantly in low Earth orbit. And we haven't had a chance to go and, for example, walk on the surface of Mars, but we can go to places on Earth that allow us to kind of simulate what that experience would be like. And so there's all sorts of places we can visit. When it comes to the science, the Antarctic seems to be, has been traditionally a favorite spot simply because of the cold, the dryness, the extremity of the environment in terms of how it impacts life is of interest. And this is simply because any time that we expand our knowledge about Earth, we give ourselves a broader base of understanding upon which we can make inferences beyond our planet. And that's why we continue to do this work. And one of the reasons why scientifically we continue to do this work. So the Antarctic's been very popular working on volcanoes because basaltic environments run throughout, the kind of near-term planetary targets of interest like the moon, like Mars. So studying these environments in terms of geology and biology and all of the chemical and physical interactions that happen between life and its physical environment are important for us to understand as we're trying to understand these two other targets. And then we can use these environments as well to put humans and robots out into them to get ourselves ready to simulate future missions. We also work underwater, so we work in enclosed kind of lab spaces like the Neutral Buoyancy Lab at the NASA Johnson Space Flight Center facilities. We work in ocean environments, we work in lake environments. Being underwater is a really wonderful analog to being in space and the tremendous difficulties that come with working in space and the dangers that come with working in space. We cannot breathe our watery environment. And so you are fundamentally constantly in that danger, if you will, when you are underwater, whether you're in a submersible or you're diving or whatever. And we obviously take a lot of safety precautions and take safety as a very important kind of paramount, priority. But it's still there. It still lingers as it does when you go to space. So you can't really simulate that on land. Being underwater, that's a great way to simulate that kind of constant, pressure of danger.
It's really interesting that some of these environments are really, when you talk about the Arctic and the Antarctic, the poles, that's a real environment that impacts you. So all of your senses, and you're really immersed in that experience. Whereas in deep sea, you're sort of shut off from that environment because we obviously can't be in that environment, just us and our senses. So obviously, if we were to go to Mars or even to the moon, we're going to be kind of shut off. From,
ensconced in a suit.
Yeah, that's right. So is part of it finding out how people will react to being in those situations and then, troubleshooting some of those things as well, because obviously those missions will be quite a long time.
Absolutely. You can't just design hardware without understanding how the human uses that hardware. Eventually you have to do that, because if we don't, then we won't figure out all the little intricacies that go into actually applying that hardware into some sort of use. And it also helps us early on to reduce the risk. If, instead of just sending humans out with new toys, you got to know that thing inside out and backwards, and you have to adjust whatever that thingamabob might be so that it's best suited to support the human. That's what we're there for. We're not there to support the hardware. We're having the hardware support us, right? And the software and the people who stay back home. With some of our projects, we don't have formal psychological studies, as an example, involved in it. Other groups do. We do have people called ethnographers and cognitive systems engineers that come in and work with us and conduct studies. And what these people do is they study the way that we make decisions. They study how decisions propagate through our system and how different types of what we call capabilities, so software and hardware as an example, how that enables or detracts from the right outcomes that we're hoping to get, and how people make decisions based on those interactions between humans and computers and hardware and computer software and humans and so forth. It's very complicated indeed. I think part of innovating and designing has to be observing that interaction between whatever it is that we've designed and engineered and the fundamental client, which is the user or the human. And without studying that, we're probably going to lose out on putting our best foot forward.
I'm thinking about all these analog locations on Earth, and I know your primary aim is to obviously have a target in mind in terms of it being an analog for you to use as a template for studying for, space and Mars. But I'm wondering, while you're out there, you're obviously collecting lots of data and you're in these environments. Do you share that data, or do you use that data directly to comment on those environments and perhaps learn a bit about those environments on Earth?
Absolutely. In fact, it's part of a required deliverable for our grants. So we not only have to take the information and the data that we recover and use that to guide, for example, mission architectures, but we have to publish on that data in peer-reviewed publications. So we recently had about, I think it was 13 different peer-reviewed publications come out in the journal Astrobiology. And those papers ranged from, the natural sciences all the way to communications to operations research. So it really it gave you a flavor of the breadth of these projects projects. And there have been many other scientific, just purely scientific publications from these projects as well. And that is absolutely a requirement. We have to put our knowledge out there into the public domain. We've got to make sure it's accessible. And that's actually something that NASA is required to do as well, is to make these data sources, available to anyone who wants to use them and apply them for further research. We make a point of ensuring that we hit that deliverable for sure.
There's the obvious part of all of this in that, the adventurers in all of us would love to see humans get to Mars. Mm-hmm. But in terms of looking at them going to Mars, what do you think the first missions will be all about?
I think it'll be very similar to what it's like if you have to set an outpost up anywhere. Yep. So, if you're establishing a new town, the first people that go out probably won't be those that are setting up banks or setting up cafes. It'll be the people that are going to dig holes and set up buildings and make sure it's livable and planting plants and things like that. So those pioneers are going to be the similar type of pioneers that and the pioneering work that we're going to have to do as we establish ourselves for long-term expeditions on the moon and then as well on Mars. So it'll be fairly, I think, focused on that, on building up infrastructure and enable people to survive in those very harsh environments. And then the trick is to move us beyond survival and just not surviving only, but thriving as well. When you get to that thriving period, I think that's going to be really fun, right? You'll have different types of skill sets that'll be required. You'll have people that may pivot on the skill set that they brought to those planetary systems and then find other ways to apply themselves. And that's part of human exploration, is people kind of shift gears and find new things that they want to get into or new ways to make money, to have commerce and so forth. And that's the type of evolution that we're looking forward to. But that'll certainly take a while, for us to move there. But certainly the first few missions will be pretty utilitarian in terms of building up infrastructure.
Yeah, so I can kind of see the parallels between us finally making it to the Antarctic, for example, and setting up outposts there.
Right.
But I guess the difference here is that the Antarctic isn't that far away from us, really.
You can still breathe the air.
You can take a ship there.
Right.
And all the supplies can come from, Tasmania or wherever you happen to be. They can come in, and so you don't have to necessarily grow a whole pile of food there. And supply ships come all the time. But with Mars, it's a long way. So
that's a great point. And there are lots of people thinking about this right now, myself included, in terms of what those initial few missions might look like. And you probably, on the first few landed missions to Mars, in terms of these human missions to Mars, you might not even have humans on them. Mm-hmm. There'll be supply ships and there'll be starships that are there to actually make resources from the resources that are actually available. And what I mean by making resources is actually making air, drinking water, return fuel, and so forth. And so those types of things will have to probably start happening before humans land. You can get into all the complexities. It's actually really fun to think about in terms of, okay, you've landed these cargo vessels and these infrastructure build-up vessels without any humans on them, and then you may start to send your crewed mission onwards to Mars, but then you have to do it in such a way that there's enough time so that if something doesn't work in terms of building up this initial infrastructure, you can return the humans, or else you just send everything that those first few humans need to land on the surface of Mars, and so they don't have to worry about, building, or they don't need to worry necessarily about building what they need for the first 450 days or growing their own food. It's all there. So there are different options, and there's sort of different ways of arranging the Tetris pieces so that it works out. But yeah, there's a lot of, it's kind of like event planning, right? There's a lot going on. So.
It's bigger than a festival, yes.
But conceptually, I mean, when you abstract it, it's fundamentally the same thing. There's just a lot of moving parts. You just want to keep these people happy and alive, right, doing their job. And you just have to make sure everything has been thought about from a variety of different angles and it makes sense, and that you give yourself options.
Yeah, fantastic. And I'd imagine that the first data coming back from the people that have landed that are happy, obviously, and healthy and quite great there, that they'll be starting to collect samples and things, and then you'll be starting to communicate back on Earth with them. Mm-hmm. And I presume we're going to send like labs with them, almost little mobile labs, so that they can start to actually
analyze what they
see.
Yeah.
And that will then impact and change what then further gets sent up. to Mars.
You're absolutely right. It's an iterative process, and that is exactly what will, in the best case, that is exactly what happens. We don't want to anchor ourselves to any set plan, because that is part of the scientific process, is as you learn more, you change what you want to learn next, or you may move in a slightly different direction or keep the same, who knows, but you have to react to what you learn. We hope we can enable these people to definitely run their own analyses when they get there, so that they themselves, who will be very well-trained, educated human beings, can make their own inferences about what to do next. And they will have a very high level as well as deep knowledge of what the goals are, and they will know how to execute to that, whether they are on their own and they have some communication lag between themselves and Earth, or whether they're in close communication with the Earth as best as possible. So all of that kind of decision making, we hope we can prepare the right capabilities for that to really flourish. But fundamentally, it's going to be very interesting, that first little bit there, in terms of how things change, because things will change.
Absolutely. And I think also it's really interesting to think that I think all of us want to believe that we're not the only species, or Earth is not the only planet that has life on it. And so
right.
What better way than to go to another planet and actually physically be there to sample? I think we've sent lots of robots there to try and do some sampling, and with some success, I think, but there's nothing like actually being there and being able to sample that, to actually see and maybe see evidence of whether life started on Mars and sort of never got off the ground, if you like.
Right. Yeah. And I mean, it's really interesting for me to hear you say that. I know you're somebody that's done a lot of lab work. You've also spent a lot of time outdoors. I think you understand that fundamentally, when the human is allowed to directly interact with their environment, there's so much you're able to synthesize and fairly quickly, that the decision making is at a different cadence than when you're sort of removed from it, like, for example, through the lens of a robot. And we have incredibly capable robots that have explored the surface of Mars, that are currently exploring Mars and other planets in our solar system and beyond. And yet there is nothing, to me, like having a human in that environment. We no longer talk, in our hallways anyways, about the humans versus robot. That's not a thing. It's going to be humans and robots. It's going to be robots and humans. It has to be together. And the robotics that we're talking about, they're not simple robotics. They're armed with all sorts of algorithms behind them that are going to help these hardware systems make decisions that will help the humans, and the humans will feed into that cycle. So it's a very complicated dance that will happen back and forth. They will all be interconnected. They will all be geared at the same objective. And so I think we're moving into an exciting kind of more illuminated, conversation now around what the future looks like.
Fantastic. I think one thing that you just touched on there that I think is so true around this is that if you're looking at something through a lens, or you're even taking a photo of something and you come back to that photo and you saw that thing, the photo, it's hard to make out all of the detail within that photo. And so if we're capturing all this data via photographs from robots, then they are good, but it's sometimes hard to make out the detail in that and what's important. Whereas when you see things with your eye, you can actually pick out those things, much more delicately. Yeah. And so, I can imagine that humans that have been sufficiently trained to look out for things that are important will see evidence of that thing before they encounter it, almost.
Right. And sometimes you won't even be able to describe exactly what it is. I don't even feel like I have the words yet to describe how I feel when I don't have to rely on the interpretation of a third party, even if it's a human, to tell me where my field sample came from. If I can be right there, there's just something, that intimacy is so much richer. And it's very difficult to explain that, and I hope I can find the words eventually, but it's exactly what you said. There's just, it's such a very different experience when you're right there. I love scientific illustrations, and I mean, that used to be the only way that we would capture, microscopic images or images of our landscape and share that with people. And then photography became a thing, and then it's become richer and richer over time. The resolution, the pixels on target is remarkable now. But there's still something so beautiful about scientific illustration to me, and I think it's because of what you said, Renee. It's that the interpretation of the person is not left up to somebody else to interpret. It is right there because they drew what they saw. and they're explaining it without words in their illustration. And, you know, when I take a picture of something, I still have to caption it. I have to draw the arrow and this and that. But when something is drawn out, I can sort of illuminate what I think was important. It doesn't mean the interpretation is right, but it certainly is very clear in terms of what the interpretation is.
I just wanted to finish off with something that I think is fairly common for people to think about. So we're talking about some of us leaving this planet and going off and inhabiting another planet. And so, first of all, I just think, before we get onto that subject, I think it will be really interesting as we look forward, obviously, multiple generations to people living on a different planet. It'll be really interesting to see how we evolve on Earth and how they evolve. You know, we all know that countries have different dialects and different customs and cultures. It'll be really interesting to study the difference there. Yeah. You know, we'll obviously send people and they'll be very similar, and they'll be Earth people living on Mars, and they'll be, you know, like people immigrating to a foreign land.
Yeah,
you know?
right.
But then after a while they'll have children, and the children won't know anything other than Mars necessarily, and they'll be going on holidays to Earth, you know, and that's kind of blows my mind to think about. But what are the cultural habits that might...
I don't even know what they'll sound like. What language will they speak? Like, you know, I have a really great friend who has done a ton of Mars research, and now she's actually at SpaceX. On you know how you get these sticky things that you put up on letters that have your address on them, so you don't have to write it out every single time. So hers says her name, her street address, where she lives in the country, and then it says Earth. And I was like, yes, because one day it will say Mars, you know, or it'll say the moon. And I was just really, when I got a Christmas card from her, I was totally struck and impacted by the fact that she put Earth. It's just so neat. And it's a reminder we're on a planet too, which is kind of an important thing to remember when we're going through, you know, and talking about all sorts of issues that are hitting us today. So I agree with you. It's going to be really fascinating a few thousand years from now just to see where humanity's gone.
I think that's a really interesting point, because where I was coming to with that is that I think many people think that we are trying to get to Mars because we're messing up this planet, so we sort of need a plan B, if you like. So
no, there's no planet B.
Indeed, there is no planet B.
No.
But I think it could work in a different way. I mean, a lot of us are really proud of the countries that we're born in, and so we identify very strongly with that. But as a planet, you know, we don't necessarily, because we kind of have this feeling that, of course, you're on Earth. I mean, we're all on Earth. No, there's nothing else out there. Whereas if people start to live on Mars, you know, people will become a lot more proud, I think, of living on Earth. You know, that'll be an identity, whereas maybe it's not currently, you know. That
is right. I love that. I hope that's the case. I hope we don't have to wait that long for us to be proud to be Earthlings, right? Like,
yes.
But I love that. I mean, yeah, that's a really interesting progression, and like, absolutely, that sounds very possible.
Darlene, I just had to very quickly butt in here. And as a huge sci-fi fan growing up as a kid, and now you working at Ames Rocket Lab, and it's blowing my mind to be sitting here across the table from you. And I've got to ask, were you a sci-fi reader at all as a kid? And
I was.
What are some of the books you remember as being really
Oh my gosh,
pivotal?
you know what? It's super embarrassing, but I can't remember the names because they weren't by anybody famous. I kind of just went to the library and got what I could get. But I'll be honest, after a while, as I started to become a teenager, I found them less and less interesting for me to read because I couldn't relate to the characters. And it's just, you know, they weren't geared towards young girls and certainly not women. And in fact, that's kind of a running theme these days. There's a lot more women science fiction writers now that have changed the landscape, but I just got bored. And it wasn't that the science or the adventure was boring. It was just the characters weren't compelling, right? But yeah, so I'm dreadful because it's also a thing. I can't remember the names of movies that I watch. Like, I just kind of watch them and it's gone. Unless they're Marvel, then my kids make me remember what I watched. But
that's repetition.
Yeah, that's it, exactly. What were some of your favorites?
There's a contemporary series called The Expanse, and we were talking about how identities develop as we colonize the solar system and kind of lose that connection to Earth. And the books in that series, the Expanse series, were for the last 10 years, there have been one out every year, and they've been a really
Did they make
influential.
Did they make a series out of this?
Yeah, there's a on Sci-Fi now on Amazon. There's a series called The Expanse based on the books. And
Right, that's so cool.
It is that really cool exploration of when we leave the planet, we don't leave our human problems behind, that we take all that baggage with us. And just because there's people on Earth and people on Mars doesn't mean that the Martians will be any more enlightened necessarily.
Dr. Darlene Lim, thanks for joining us today and for being part of National Science Week as our Science Week guest for 2019.
It is totally my pleasure. Thank you. Thank you for having me here.
Thank you for joining us. You've been listening to Climactic, the flagship podcast of the Climactic Collective, a podcast network dedicated to lifting the voices of the climate community. You can find out more about the people behind Climactic and all the shows we produce at climactic.fm. We are a social enterprise podcast network, and we greatly appreciate your support. You can find a link to our Pozible where you can support us directly in the show notes of this episode or from our website. Thank you for listening, and from the whole Climactic Collective, keep up the great work and take care of each other in these climactic times.
The Climactic Collective.